Hey folks, welcome back. In this video we're going to go over the age of the universe, so let's get into it. So it starts off by saying the age of the universe is thought to be around 13.8 billion years, and that's the same as 13.8 times 10 to the 9 years. And this is commonly asked in things like multiple choice questions in the exam, where they'll maybe put this in a statement saying that the age of the universe is 13.8 million years old. So they often try and catch you out by trying to say that it's 13.8 million years rather than 13.8 billion years. Or you could just remember the rough estimate of about 14 billion years. And how do we know this? Well, there's lots of evidence to suggest that the age of the universe is this value. It says we know that the universe is still expanding, the galaxies that we can observe are accelerating away from us. And this gets at the idea of Hubble's law, which you'll see again in higher physics, which tells us that galaxies further away from us are actually moving at a greater speed than the ones closer to us. And that suggests that these galaxies are accelerating away from us. It then says that as galaxies move further away, the light coming from them is redder than what it should be. This is known as redshift, also commonly known as Doppler redshift. And to help you understand the idea of redshift, I'm going to show you a picture here. So here we have a galaxy emitting light, and if you're a distant observer viewing that light coming from the galaxy, then because we know that the universe is expanding, that means that the light waves moving across space must also be stretched out as space expands. And that tells us that the wavelength of these waves gets bigger, i.e. it shifts towards the red end of the visible spectrum, where you've got red light at one end and blue or violet light at the other. So red light is the greatest wavelength in the visible spectrum, and blue or violet light has the smallest wavelength. And what we detect from galaxies moving away from us is that their light is actually shifted towards the red end of the spectrum, and that means its wavelength is increasing. Now that doesn't mean that the light itself necessarily turns red, it just means that it shifts towards red. So for example, if the light was a green wavelength to begin with, then it could shift to say the orange wavelength, which is a greater wavelength. But the light itself doesn't have to change to red. So we can see that for galaxies moving to the right here away from this observer on the left, the light waves are stretched out, and this is known as redshift. And it's worth also pointing out the case which we don't actually observe, which is blue shift. And this is where the light from distant galaxies would shift towards the blue or violet end of the spectrum, i.e. decrease in wavelength, which means the waves are squashed up. And this is what would be observed if galaxies were moving towards us rather than away from us. But we know this isn't the case, as we don't detect these blue shifts of light. Going back to the notes, it says here, if we know the rate at which galaxies are accelerating, we can reverse the process and see how long it would take to come to a single point, which is known as the singularity in the Big Bang. And to visualize this, I'll just show you a quick simulation. So here you'll see a wee dot called a singularity, and this is thought to be the single point of matter from which the Big Bang started. So if we click play here to go forward in time, you'll see the universe expand from that single point, the singularity. And notice how the space between these galaxies increases as the universe expands, but the size of the galaxies themselves doesn't actually increase. And we're saying if we know the rate at which galaxies accelerate away from us, then we can reverse the process and go backwards in time to work out how long it's been since the Big Bang. So if we click backward in time here, then we just reverse the process. And we eventually get back to the singularity, and you can actually do a calculation to work out the age of the universe, but that's seen in higher physics. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video one of these, subscribe to the channel, and I'll see you in the next one. Take care.